Hello, welcome to this video. This is on buffer solutions, and Lezanani gave me this one. It is from summer 13. Let me get a nice pen. All right, this is from summer 13, question paper 42. I don't know the question number, but I think that's enough, isn't it? You can find it from there. And it's on buffers. And if any of you want a video, could you please give me the variant and the year and the session, because it takes me ages to find these things. Okay, obviously sometimes you don't have them, but if you do have them, just give me that information, all right, and then I can find it directly. All right, so we've got to add a buffer solution. This is made using 1 cc of 1 molar ethanoic acid plus 1 molar sodium ethanoate. And this time we've got to find out how much we add, the volume of each solution we have to add together to make 100 cc's of a buffer solution with a pH of 5.5 and everything else. Show you're working. So the first thing I'm going to do is I'm going to give the equation of, because this is how I always like to start things. I always like my equation, my buffer equation, where it comes from. And there it is. There's my acid. Okay, and from the acid, I can work out my Ka. And my Ka is the base times the hydrogen ion. Whoops, wrong sign there. It doesn't really matter, does it? But make it look nice. Times my hydrogen ion concentration all over the concentration of the acids. There you go. And from this we can see that Ka over the hydrogen ion concentration is equal to the base part of the buffer over the acid part of the buffer. Okay, so now we've got to use a little bit of maths, haven't we? Well, we know the total volume is 100 cc. Okay, so let me put in my Ka first. My Ka is 1.79 times 10 to the minus 5. My H is 10 to the power of minus 5.5. That's this, isn't it? I'm using that. Is equal to, now what am I going to do? Well, I know that they're both 1 molar. Okay, so but I've got to find the volume now. So I'm going to say the volume of my base, this one, I'm going to say the volume is X. Okay, now what's the volume of the acid? Well, it's got to make up to 100, so it's got to be 100 minus X. Okay, now why can we do this? Why can we put a volume over a volume when in this one it's a concentration over a concentration? Well, the reason we can do that is because it's a ratio and the volumes will cancel out. Okay, so basically X over 100 minus X is the volume to volume ratio. It's also the number of mole to number of mole ratio. It's a ratio. Okay, and we can get away with lots of naughty things with ratios because volumes are going to cancel out. Okay, so let me work out this side. I've just worked this side out and I think I get 5.66. Okay, is equal to X divided by 100 minus X. I did this earlier, I'm not cheating. All right, now let me put it up here. Now, cross multiplying or whatever, I get X is equal to 566 minus 5.66X. Therefore, X is equal to 566 over 6.66. I hope you understand what I've done there. I've taken this over there to make 6.66x, and then 6.66x equals 566. Therefore, x must equal this. Okay, so let me do that. You can try this on your own if you want, if you don't believe me. Okay, and you get 84.98, which is about 85 centimeters cubed. Okay, so in other words, I need 85 centimeters cubed of my salt, because I've defined this as the salt, didn't I? Divided by, well, this is 85 centimeters cubed. And the volume of the, sorry, got it the wrong way around there, didn't I? Gotta get rid of that. Okay, sorry about that. All right, this is my salt, so this is 85 of this. And therefore, if it's got to make 100, so I need 15 of this, won't I? Okay, and there you go. It's a tricky question for sure. All right, so well done, Lezanani, for asking, but it's a tricky question. Now, again, if you have any problems, give me a shout and I'll redo it if I've done it wrong. All right, and now she sent another one. Where's the other one? This one. All right, I'm going to get rid of all this because it's on film. Oops, that's not the right one. That's the one we've just done. Okay, so get rid of this. And I don't quite know what she wants me to do with this one. I'm assuming it's the one at the bottom. Okay, so let's move it up. The others, I guess you can figure these out. If you have a problem, give me a shout and I'll talk about those. But I'm just going to do the calculation at the bottom. Okay, now I haven't done this, so I hope this works. Calculate the pH of a buffer solution when 10 cc's of that is added to 10 cc's of that. Okay, so first of all, what is a buffer? This is going to be an acidic buffer. And an acidic buffer is an acid plus its salts. Okay, the same salt, and it should be a weak acid, shouldn't it? So weak acid plus its salt. Okay, so now what are they trying to trick me with? Well, they're giving me some acids, and they're giving me some sodium hydroxide. Now, when I add the acid to sodium hydroxide, I'm going to get the salt, aren't I? So that's where the salt comes from, plus water. Now, if I add too much sodium hydroxide, I'm going to end up with the salt and excess sodium hydroxide. So that's not going to happen. If they give me exactly the right amounts of this and this, I'm going to end up with the salt and nothing else. So that's not going to happen. So without me even looking at the question, I hope they're going to give me some sodium hydroxide and the acid is going to be in excess. So what am I going to end up with? I'm going to end up with some of the salt and some of the acid left over. And that is my buffer solution. And once I found out the buffer solution, then I can go on and find the pH. Okay, so let's hope I've got this the right way around. Let's get rid of all this. And again, if you have a problem, please give me a shout. So the first thing I'm going to do is I'm going to add, what is it? Is it ethanoic acid? It's always ethanoic acid. Ethanoic acid plus sodium hydroxide. I'm going to get my salt, which is sodium ethanoate, plus water. All right, first thing I'm going to do then, number of moles of the acid. And then I'm going to find out the number of moles of the base, of the alkali. Number of moles of the acid is CV. So C, what's C for the acid? There it is. There's the concentration, 0.25 times V of the acid. It's 10, isn't it? I hope I'm doing this right. 10 times 10 to the minus 3, because it's got to be in whatever we call those things. The other one is going to be 0.1 times 10 again. Times 10 times 10 to the minus 3 is equal to that. Let me do this, 0.25 times 10 exponential minus 3, and that gives me 2.5 times 10 to the minus 3. Okay, I should use 3 sig fig, but I'm going to use 3 sig fig when it really matters. All right, and the number of moles of alkali is 0.1. This one should be easy. It's going to be 1. I could do that one in my head. 1 times 10 to the minus 3. So as you can see, as we were hoping, there is more of this, which we wanted, didn't we? So let's have a look. Let's write underneath what color. I'm going to use yellow. So I'm going to write down 1 times 10 to the minus 3 there. That's this number. It's going to give me 1 times 10 to the minus 3 of that, isn't it? And how much acid is going to react? 1 times 10 to the minus 3. So how much acid is left? Well, it's what we started with, 2.5 times 10 to the minus 3 minus 1, whoops, there's 1 times 10 to the minus 3. It gives us 1.5 times 10 to the minus 3 moles. Okay, how much salt do I get? I get 1 times 10 to the minus 3 moles. So now, that's the first bit. Next bit I'm going to do is I'm going to figure out what does Ka equal. Now, I always do this. You might think I'm being a bit silly, but I like to know everything. Okay, there we go. It's going to equal that divided by this. Okay, to be honest with you, I'm sure you can remember this, but I like to derive it all the time. Now I'm going to jiggle this around and get H plus as the subject. So that's going to equal Ka times the acid concentration divided by the salt concentration. Okay. All right. So what does that equal? Ka is equal to 4.7. So pK is 4.76. So Ka is 10 to the minus 4.76 times the acid concentration. Now I've got the number of moles of acid here. Okay, now as we saw in class, I can just put that in, can't I? I can say 1.5 times 10 to the minus 3. That's the number of moles. Why aren't I using the concentration? Well, because the volume will cancel out, because the volume is going to be 20, 10 plus 10. I could divide it. I'm going to divide this by 20 to show you what I mean. But it was some point in class that said we don't have to, if you remember. Divided by the base concentration. There's the number of moles of base. 1 times 10 to the minus 3. And I'm going to say the concentration divided by 20. But as we can see, these are going to cancel out, so we don't need those. All right, now let me move this up a little bit. All right, and then I should be able to figure out my H plus. I don't know what the answer is, by the way, of this. I'll see if I can find it out before I finish. All right, so 10 to the power of minus 4.76 times, oh God, that looks weird. Yeah, times 1.5 exponential minus 3 is equal to that. Oh, it seems to be working. Divided by 1 exponential minus 3. Oh, it's a very small number. Let me count. 1, 2, 3, 4, 5. It's 2.61 times 10 to the minus 5. That's the H concentration. Now let me find the log of this. Log of that of 2.61 exponential minus 5 is equal to, I get 4.58 moles. Oh, that's what we're talking about. It's not moles, is it? 4.8. So that's the H. This is the pH. I think that's the answer we got before. All right. So I'm going to stop there. I'm pretty sure that's right. If it's not, give me a shout. Please tell me if this is what you wanted. Okay. I want to stop now because the video is going on too long. By the way, if you think I go a bit too slow, why don't you play me back at 1.5 or even 2? Okay. If I'm going too slow for you, save yourself some time. All right. Bye bye.